Hello, this is our boat trip project. I'm Isaac Long.
And I'm Joshua Marshall.
And I'm Pablo Carcano.
Our group, we're the Costco guys. We are three members. As a group, we wanted to learn how corrosion affects underwater cables. We researched and learned a lot on the topic. Our agreement helped in a big way. We all knew our roles and brought what we learned to each other. When we decided our roles within the group, we had clear tasks and goals and avoided confusions and confrontations. Isaac Long, I am in charge of giving a general summary slash overview of our project and its thesis. I was also tasked with researching how the rates at which deep sea cables erode differentiate based on their depth. Our project is about analyzing how corrosion affects underwater power cables, especially as the demand for them arises with offshore energy systems. This intersects heavily with the coastal environment because saltwater wave activity and seafloor conditions all contribute to cable degradation. Chemistry plays a key role as corrosion is an electrochemical process influenced by oxygen levels, salinity, and material composition. Our thesis is that the corrosion slows significantly in deep ocean environments, which can guide safer, long-lasting cable designs.
Our solution that we came up with as a group was after researching our corrosion systems in an environment underwater, we came to the conclusion that the most effective solution was to use denser and more corrosion resistant materials in the construction of these said subsea cables. These materials, like alloys, showed significant lower corrosion rates, especially in deep sea environments with reduced oxygen and biological activity near them. By upgrading the standard materials used in the cable design, we can improve their durability, extend their lifespan, and reduce the risk of failure or costly repairs. But especially, this solution not only supports more reliable coastal offshore power systems, but also directly addresses the chemical challenges posed by saltwater and moisture. I'm Joshua Marshall, and I was in charge of implementing our geographical findings or corrosion from our boat trip and the coordinates that match. I was also tasked with additional research that directly related to our thesis that we came up with. So as you can see in the diagram, there's two pictures. Number one, the Ensco oil rig, and number two, Pelican Island Bridge. These two pictures shown above are the two findings that directly matched our thesis the most because of the electrical system and signals that are used within these two structures. Both structures use power systems that have some essential cables running under them and all around their structure itself, which in this case would be directly affected by the saltwater and oxidation around it, causing possible damages to the subsystems and therefore causing a multitude of problems to occur. The solution that we came up with was previously mentioned was the use of denser and stronger materials for the construction of the cables in order to achieve a higher rated standard of protection to avoid any damages caused by corrosion.
Hi, I'm Pablo, and I was in charge of the literature slide. I was also the team facilitator, and I would communicate with the group what needed to be done by when and aided in setting up meetings. Some initial proposals I brought were when we brainstormed for the thesis proposals. Do deeper cables rust faster? And does more oxygen-rich water accelerate corrosion? What we learned. In our research, we found that the biggest cause of corrosion on underwater cables is the weathering caused by rubbing against the ocean floor and other underwater debris. In order to combat this, these cables are wrapped with multiple layers and insulators for protection. I think the most interesting fact we found was that the cables laid at deeper oceanic depths experience slower corrosion and longer lifespan, validating the hypothesis that deeper marine environments are less corrosive compared to shallow ones. This is due to there being less oxygen the deeper you are underwater.
So these were our sources that we used. Majority of them were found from the ACS journal as well as the IEE journal. They were both very standard engineering practices. And yes, thank you for viewing our presentation.
Thank you.
Thank you. Boom.
I like it.